In this video, I'm going to show you how to solve this problem. The acceleration of a particle is given by the function a is equal to 2t. The particle's velocity and position are both 0 at t equals 0 seconds. What are the velocity and position of the particle at any time? So, we know that the acceleration is equal to 2t and that the velocity is equal to the integral of the acceleration with respect to time. Now the upper bound is the time and the lower bound is 0, since the initial time is 0 seconds right here. Now we can just simply solve this. We can substitute a equals 2t, so this would equal the integral from 0 to t of 2t with respect to t. Now if you use the power rule, this simplifies to t squared. And then we're going to take the value of that from the upper bound is t and the lower bound is 0. So that is basically the function for the velocity. And now we're asked to also find the position of the particle. Now the position is equal to the integral from 0 to t of the velocity with respect to t. Now we know that the velocity is equal to t squared here. So we can simplify this into the integral from 0 to t of t squared with respect to t. Now this can be simplified to t cubed over 3. And now since 0 cubed over 3 is always 0, this will just simplify to t cubed over 3. And that is the function for the position of the particle. And that is how you solve this problem.